air pollution on health and productivity. It might seem that this event is happening slightly in an off season because the peak season of air pollution is perceived somewhere in October and November. But we are, of course, way above the normal air quality limits even today. No talk on air pollution can be complete till the time I state the PM 2.5 today. It's 161, so well above the limit. So yeah, it's a very important topic. I'm sure the audience members here do acknowledge that. So we have here today with us Dr. Alex Tabarrok and Dr. Divya Dutt. So Dr. Alex Tabarrok is a professor of economics at George Mason University and holds the Barclay J. Medin Chair in Economics at the Mercatus Centre. His research focus is on the topics of health economics, alternative political institutions, and empirical law and economics. He has also co-founded Marginal Revolution University, which is an online platform for learning economics. And we have Divya Dutt. She's a program manager officer at United Nations Environment Program, which is responsible for UNEP's program portfolio in India. She is an economist with close to 20 years of experience in applied policy research on environmental issues. And before joining UNEP, she was at the Energy and Resource Institute, TERI, in New Delhi as a senior fellow. So the program of this event is going to be as follows. Dr. Tabarrok is going to give his presentation for around 40 minutes. Brookings is going to give like a very short presentation of around 10 minutes about the kind of work that we do in this domain for another 10 minutes. Divya is going to give her comments following the presentation by Brookings. And then for the last 20-25 minutes, we'll open the floor for questions. Thank you.
All right, thank you very much. It's really great to be here. I think we all understand that pollution is bad. It's really no surprise. Two recent studies from the IHME and from the WHO actually show that air pollution alone kills about 10% of all the deaths every year, about 6.5 million people. So what this means, in fact, is that air pollution kills more people than AIDS, malaria, and tuberculosis combined. What I want to show today, however, is that a series of recent papers with more really credible research designs actually show that pollution is even worse than we thought. Worse for health, worse for cognition, worse in a variety of different measures than we even thought before. And I'm going to cover a bunch of papers. I want to begin with this paper by Janet Curry and Reed Walker. This is looking at infant health and pollution in the United States. So motor vehicles are one of the biggest sources of air pollution. They account for about 50% of carbon monoxide, 34% of nitrogen dioxide, and about 10% of PM 2.5, which is this fine particulate matter, which appears to be especially deadly. What they're going to be doing is, what they're interested in is the effect of this air pollution on infant health. Now, the key problem here, as with all kinds of empirical studies, is how do you know what's causing what? So, in particular, people who tend to live in polluted areas, they're not the same as people who live in areas with less pollution. They tend to be poorer, for example. They tend to have different demographics, and so forth. So if you find a correlation between pollution and worse health, how do you know that that's caused by pollution? How do you know that it's not caused by some other factor? So to kind of solve this problem, what Curry and Walker are going to do is they're going to look at a natural experiment, which was the introduction of electronic tolling, Easy Pass, in New Jersey and Pennsylvania around the year 2000. And it's a pretty clever study. So the idea is fairly simple. The top picture, you have the old kind of toll booths. And what happens? You come to the toll booth in the old days and you give your money, and then they say, oh, I need to give change, and they give you some change, and you say, how are you, Bill? And they say, I'm doing fine, see you tomorrow, okay? And you have a lot of congestion. Right, so it looks like, you're gone or something like that. You have a lot of congestion at the toll booth. Then you have the introduction of Easy Pass. around the year 2000. So now people have this device and they just zip through the lane, okay? Much less congestion around the toll booth. And what that means, of course, is much less local pollution. Okay? So once Easy Pass is introduced, that local pollution declines quite quickly. So the idea of the study then is to compare the health of infants who are born near toll booths before Easy Pass is introduced with the health of infants who are born near the toll booths after Easy Pass is introduced, and to kind of control for other factors which are changing through time. They're going to compare that difference, before and after difference, with a before and after difference of a control group, a group of infants whom we think their dynamics over time would be similar to what the treatment group would have had without the introduction of Easy Pass. Just to make this clear, what in fact they're going to do precisely is the treatment group are mothers and infants who are born in the yellow circle. That is within 2 kilometers of a toll booth. They're the treatment group. They have a lot of pollution before Easy Pass, much less pollution after Easy Pass. The control group is going to be infants who are outside of the circle. They're outside of the yellow circle. So they're more than 2 kilometers away from the toll booth. So they're not influenced by the toll booth. But they're within 10 kilometers. And they live within 3 kilometers of a major highway. So the idea is that the control group will have similar dynamics. They are going to have similar demographics and going to have similar dynamics over time. So this is what is called a difference in difference study. Okay, what do they find? Okay, pretty simple. Simple difference in difference. What they find is that after the introduction of Easy Pass, the incidence of premature births for children and mothers born around near the toll booths was reduced by 7.4%. And the introduction of Easy Pass, again for these children, reduced the incidence of low birth weight babies by 8.5%. Now these are big effects, because being born premature or being born with low birth weight, this can have implications which last a lifetime. So children who are born premature, they may have health defects which may not even show up until they're much older. They have quite possibly diminished IQ, diminished cognitive behaviors, and so forth. So these are very large effects. The next thing they do, the authors, is, well, let's add some controls for precision. All right? So they say, okay, we're going to control for whether the mother was black or Hispanic. What was the education of the mother? What was the mother's age? Did the mother smoke? What was the infant's gender? The birth order, the year, the month, lots of other control variables. Okay? And what they find, bottom line, is very similar effects. So even introducing a whole bunch of controls, they find that premature births fall by 8.6 percentage points, and low birth weight babies fall by 9.3 percentage points, even if slightly larger effects, in fact. Very nice aspect of this study is that there's also a dose-response relationship. Which are the children, the infants, whom you would most expect to be influenced by the pollution put up by the toll booth? It's ones who live near the toll booth, the nearest ones. So that's in fact exactly what they find. The first graph shows before and after low birth weight by distance. So the horizontal axis is distance to the toll booth. And what you see is that the big drop occurs for the infants who lived nearest to the toll booth. And the effect is biggest for those who are very close, and it gets smaller as you move farther away. So there's a dose-response relationship. Same thing with premature birth. The biggest effect occurs for those children who are born very close to the toll booth, and the effect gets smaller as you move farther away. So again, a dose-response relationship. This is consistent with evidence we have from a number of other studies. I'll talk a little bit more about that. Also want to point out, is something which will come back later on, is that an interesting aspect of this study is when we talk about externalities in economics, when we talk about the influence of pollution, the effect of pollution on other people, we say, okay, the way to solve that with a tax. Okay? So, or we need some control. Okay? We need to stop this. But this is an interesting example in that we made it better for the infants. We reduced pollution. We also made things better for the drivers. Right? We reduced their time to get to work. Right? So when thinking about how to control pollution, I think we might jump to a tax or something like that too quickly. What we really want to think about, if we can, if it's possible, is to think about win-win solutions. Okay? These are going to reduce the political opposition to controlling pollution if we can find technologies which make everyone better off, which make both the emitters of the pollution, in this case the drivers, and the receivers of the pollution, in this case the infants, if we can make them both better off with better technology. So if we can make solar technology, if we can improve the distribution of electricity at the same time as we make electricity higher quality in terms of pollution, that's a much better possibility of getting that through the political process than something which is just like a tax. Okay. What is compelling is that there's lots and lots of studies like this. So briefly, this another study looks at a agency in China. This is a travel agency, and this agency has got a bunch of call center workers in Shanghai and in Nantong. Okay. And what is interesting about this paper is that the agency measures the productivity of their workers very closely. Because the main thing that these workers do is the answer the telephone. And it's a travel agency, so they got to be talking with their customers on the phone. So their employer, C-Trip, their employer knows the number of phone calls per shift. Okay? They know the number of minutes that these workers spend on the phone every day. They know the number of minutes they're logged on to the computer system that they're working. What the authors then do is, using meteorological data from meteorological stations in these two cities, they look at basically PM10, which includes the smaller PM2.5, and they measure that at the city level. So they have, on a daily basis, how much pollution is there? Is this a low pollution day? Is this a high pollution day? They have a couple of years of data, like 2 years of data. What they find is that workers, they show up on high pollution days, but each 10-unit increase in the API, a measure of pollution, reduces a worker's calls per shift by 0.35% and minutes logged onto the system by 0.25%. Both of these effects are measured taking into account the worker's average level of productivity. So this is deviations from a worker's average. Some workers are more productive than other workers, but on average, all of them are reduced by about 0.35 or 0.25%. Now, is this a big number? Okay. What this means is that a 50-point increase in the API, which is not uncommon, that can happen quite often in a year, that reduces productivity by about 1.75 to 1.25%. Okay, let's say 1.5%. Now, remember, this study is measuring the air quality at the city level. So if these workers are representative of workers in a modern economy, sort of knowledge workers, okay, if these workers are representative, then that means when you have a 50-point increase in API, the entire city has a reduction in productivity of 1.5%. Those are big numbers. So you have cities with millions of people. So if these numbers are reflective of what is going on in a modern economy, and I think they probably are, this means on high pollution days, the entire city is less productive. Often because of simple things, because they have sniffles, right? They need to go to the restroom more often. It's a little bit harder to concentrate, and so forth. This effect is especially clear on high pollution days. And yeah, this affects millions of people. Millions of people. A little bit of evidence that this is not spurious, okay, or robustness test, is that the negative effect, it happens on the day of the pollution, okay? So previous days of pollution don't seem to matter that much. It's the day that the pollution happens where you have the negative effect. And the effect also, future days do not influence current productivity decline. So we would be very worried if future pollution were to reduce productivity today. That would tell us that our study is sort of messed up, right? Because future pollution should not influence current productivity. And that, in fact, does not happen. So that tells us the study is robust. It passes that test. Passes that test. This idea about knowledge workers. Again, I think this is where we have learned a lot in the past few years. Because traditionally there were a number of studies showing that, you have high pollution, that fruit pickers, they pick less fruit, or construction workers, people who are outside, okay, doing manual labor, they're less productive. That was known. But now what we're discovering is that knowledge workers also become less productive. So this is a pretty cool study. What these economists did is they had air pollution measures in a building, and they had these in where there was a series of chess tournaments in Germany. Okay. So these chess players, these are competitive tournaments, they want to win. And they have measures of air pollution sort of by room, okay, over time. And what they do is they look at all the moves, the chess moves that the players made. And they say, what should the players have done? Okay, how do they figure that out? They say, well, according to the world's greatest player of chess, what were the best plays? What moves should the player have done? So what do? Did they get world's greatest player of chess, Magnus Carlsen? No. Stockfish 9, okay, which is the AI, right? World's best chess player now has a ELO much higher than Magnus Carlsen. Okay, so the machines rule. So they compared what Stockfish 9s said the players should have done to what the players actually did. And then what they showed is that an increase in 10, this is micrograms per meter squared, in PM 2.5, an increase in these small particulate matter, this fine particulate matter. This raised the probability of making a meaningful error by 18.5%. It raised the probability of making an error in these chess games by 18.5%. And remember, these workers, these chess players, they want to win, okay? So these are guys who are concentrating as much as they possibly can. And when pollution is high, they're making more mistakes. So it's not just call center workers, it's not just agricultural workers. These are knowledge workers, cognitive workers at the very highest levels are influenced by pollution. Here's another example of a cognitive task. This is Major League Baseball in the United States. The umpires are evaluated by a 3-camera computer system. And what the umpires have to do is to call balls and strikes. Okay? And a ball and a strike, it varies depending upon the player, because it determines if the player is really tall, you get a different strike zone, and if the player is short, you get a different strike zone. So it's a complicated task. They have to see very carefully, and they have to be able to evaluate very quickly. They have to think quickly to be able to see what's going on. And these umpires they're evaluated by the computer system, which of course is very good. And if they make too many mistakes, they're called into the office and say, hey, what's going on? You're making too many mistakes. And if they continue to make mistakes, they're out. So the umpires have good incentives to be careful. This is the kind of thing, the data that they have. Did they call a strike when it should have been a ball, or a ball when it should have been a strike? Okay. Sorry, I don't have a cricket example.
Why?
Yeah, why? Something like that, right? Yeah, I don't know the lingo, but there you go. Same kind of thing. Okay, what do they find? What they find is after controlling for a wide variety of other factors, including the temperature, the humidity, the position of the sun relative to the umpire. Okay, so they calculated every day, they know where the stadium is and so forth. Pretty cool. They find again that an increase in fairly small increase of 10 in the PM 2.5 in the 12 hours prior to a pitch causes a 2.6% increase in the probability of making an incorrect call. Pretty big, pretty big. Again, biggest effects appear to happen at the highest pollution levels. And this is high according to the US standard, right? Pollution, as you well know, is much higher in India than in the United States, on average. I like to say, trust literature is not papers. Every paper has flaws. And so what you hope is that when you have a number of papers, those flaws sort of cancel out. And here I think what is important is there's a very large and growing literature, all pointing in the same direction. So there's a paper by Ebenstein et al. They look at nationwide tests in Israel for going to college. Okay, these big tests, all the high school students have to take these tests. And what they find is that students who are unlucky enough to have to take the test on a high pollution day, they score lower, and remarkably, this can affect their entire career. So if you take the test on a high pollution day and you score just below some cutoff, you don't get in to the very top university. And your entire career can be changed by a small factor which reduces your scores by a little bit. Heisel et al., this is a US paper. They look at what happens to school children who switch schools. When you go from junior high to senior high, right, students will switch schools. And sometimes what happens is the students will switch from a school which was upwind of pollution to one which was downwind of a major highway. So they switch to a school where the wind is blowing from the highway onto the school. Okay? And what they find is that when students switch to a school like that, their scores go down and behavior problems go up. And the nice thing about this study is that it's a within individual study. So they're looking at the same individuals, first at a school upwind of pollution, and second at a school downwind of pollution. So it's the same student at a different school, the same student at a school with more pollution scores lower and has more behavioral problems. Same students. Paper from Mexico finds that closing down of a major refinery in Mexico City, that actually when the refinery closed down, workers who lived in that area but who did not work at the refinery, they actually work more. They work more. Why? Because they're less sick. Paper from India looks at garment workers, okay, and finds that on high pollution days, garment workers make more mistakes, reducing productivity. Lots and lots of these studies. Let's turn now to India specifically. We know that pollution in India is among the highest in the world. And we don't, however, have very good micro data, either on pollution or on morbidity or mortality. This, I think, is an area which needs to be improved. We need more meteorological stations to measure things like PM 2.5. So more of these studies can be done in India. Although we don't have the micro data, there is data from satellites. Satellites can measure PM 2.5 at the broad level. So this paper by Dean Spears and co-authors measures air pollution between 2001 and 2015 from satellite data, and then it correlates. It finds the pollution from the satellite data, and what they do, they correlate it with districts. So they find for each district and for each month how much pollution was there in that district in that month. Okay. Then they're going to be using the demographic and health survey, which covers several 100,000 children across 240 districts, and they look at height relative to age. Okay? Height deficits, height relative to age. And the basic idea here, I think, is well known. Height per se is not necessarily all that important, okay? But height relative to age is often an indicator of many other health problems. So it is correlated, for example, with infant mortality. So we know that where people have height deficits, infant mortality also tends to be very high. And we know that height deficits are also correlated with other measures of health, including infant mortality, but also adult mortality, adult income, okay, and adult IQ. So this is a proxy. The height deficit is a proxy for many other health considerations. Again, we face the usual problem, which we do in statistics. How do you know that it's the air pollution which is causing the problem relative to other factors? Okay? People who live in districts with a lot of air pollution are not necessarily the same as people who live in other districts. So to remove these other factors, what Spears and his co-authors do is they look at how deviations from the average, from the mean level of district air pollution in a particular month, okay, how those deviations influence deviations from the mean height to age deficit in that time and birthplace after controlling for a wide variety of mother and place characteristics. So to put this in a different way, the basic idea is this. If pollution in a district is unusually high relative to that district's seasonal average, and that district's monthly average, are infants born in that district of lower height than you would have otherwise predicted, knowing a lot about where, when, and to whom they were born. So they control for a whole bunch of other factors and ask then, are deviations, are places which have, if you are born in a place, if you are born in a place and time with above average pollution, are you shorter than expected? And the answer is yes. The answer is yes. Okay. And this is true. More pollution than expected leads to lower height than expected. This is a small effect, but it is consistent. And interestingly enough, it's consistent across mothers of all types. So one way in which we could measure different mothers is by the height of the mother. So mothers who are taller may have higher income. Okay, they may live in different areas and so forth. But the question is, can you escape bad air? And the answer is no. The answer is no. So even if your mother is tall, okay, probably means you're born in a pretty good place, pretty good environment. If you were born in a month in which pollution is unusually high, you have an expected height deficit. You cannot escape. Spears conclude in 2012, 26 million children were born in India. Our findings imply that at least 1 million fewer of these children would have gone on to become stunted in the absence of particulate air pollution. Fewer too would have died, and almost all of the survivors would have grown and developed towards lives that would have been a little bit healthier. Now, it's also the case that pollution increases medical costs. This is another cost of pollution. Right? The Lancet Commission estimates that 39% of ischemic heart disease and 56% of COPD, this is emphysema, lung types diseases, okay, are caused by air pollution. We don't have very good data by country, especially not for developing countries. But in Sri Lanka, which is one of the few countries, developing countries, which collects pretty closely this data, they find that 7.4% of healthcare spending was due to air pollution. 7.4% of healthcare spending due to air pollution. So another cost of air pollution. Now we hear a lot about climate change, right? And it is true that climate change is bad, you know, we want to avoid it, blah, 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 blah. I think it's also true it's going to be especially bad for India, which is both hot and wet. This is the worst condition for climate change. Well, what I want to emphasize is that, look, it's really hard to get people to sacrifice to improve the climate for future generations in other countries when it's even hard to see the benefits, right? It's hard in the United States to convince people to sacrifice for future people in other countries. It's going to be even harder in India, I think, to convince people to do that for partly good reasons. But all of the effects I've been talking about, okay? All of the effects I've been talking about, the negative effect of pollution on infant mortality, on stunting, on IQ, on productivity, on heart disease, on cancer, these are current costs for the current generation. So this is a much, much more compelling way to confront the cost of pollution. Say, this isn't important. It's important not just for future generations in other countries and for the climate and Mother Earth and whatever. This is important for children now. This is important for elderly people now. This is important to increase productivity now. That, I think, is a much more compelling way of putting the problem. Now, even with that, however, right? Although pollution is killing people now, it's making them poorer now, many but not all of these costs take a long time to develop. And they're dispersed over large populations. And they're poorly measured. And even more poorly understood by the population. So I think this explains why the politics here is very bad so far, at least. Okay? So we get kind of a recipe for political disaster. We get things like this, you know, banning e-cigarettes, right? This is crazy. This is ridiculous. And I should point out, the United States has done exactly the same thing. So, you know, stupidity is, you know, cross-country, okay? This is like, I mean, banning e-cigarettes when you go outside and the API is 300, that's crazy. Makes no sense whatsoever. But this is kind of, or, you know, in Delhi, the car days, right? You know, odd and even days. This is crazy. This is not in any way a solution which is appropriate to the scale and the dimensions of the problem. Okay, this is not even a Band-Aid. This is like nothing. Now, how do we address this, okay? Well, I think the way to address this is to change how we think about pollution. Because there's this old story, right? That pollution, okay, it's bad, but it increases GDP. And there's this old story that pollution, well, you have to go through a phase. The United States, when it was poorer, it had worse pollution. Japan, when it was poorer, it has had worse pollution. And India and China, they have to go through this stage of bad pollution, but then they get rich, and then they can afford to reduce pollution. Right? This is an old story. You can only afford to reduce pollution when you're rich. And I want to say that that story is wrong. Okay? What I want to argue is that what a lot of these new results indicate is that in fact we may be in a situation where we can be both healthier and wealthier at the same time. Now why is that? It's because, yes, pollution reduces health. Pollution reduces labor force participation. Pollution reduces productivity. Pollution reduces IQ. It disrupts behavior. In short, pollution is an attack on human capital. So amazingly, at the same time that countries are investing in increasing human capital, sending more kids for education, improving their education, at the same time, pollution is working against that. Right? So this is like, in the United States, we say, don't smoke, and then we subsidize tobacco. Okay? So here, we're trying to increase human capital through education, but we have lots of pollution, and that is working in exactly the opposite direction. So in fact, I think we may be on the wrong side, what you might call the pollution Laffer curve. Okay? We may be at a position here where less pollution actually means more GDP. Okay? So there isn't this trade-off, which we've long thought about. In fact, we can be healthier and wealthier. Reducing pollution on the margin can actually increase GDP because all of the negative effects of pollution are actually bigger than we thought. Okay? They're so big that we've gone too far, even for GDP. We're not even maximizing GDP. So less pollution can mean more GDP. We can be healthier and wealthier. There's an opportunity for double dividends. Thank you all very much.
Thank you, Dr. Tabarrok, for a fascinating talk which covered not just one domain but so many. And I'm glad that you covered India as well. It covers a part of the studies that we are working on. But let me take you all through some of the kind of work that we are doing at Brookings. I already mentioned the AQI for today, which is around 161, but let's talk about the number of people who are actually exposed to the harmful level of pollution in India. So close to 60 million people are, that's the level of population that is exposed to dangerous level of pollution in India, the standard that has been set by the central authority. That's more than 50% of our total population, and that figure goes up even further if you're looking at the urban areas. 77% of the population in urban areas is actually exposed to, again, dangerous levels of pollution. Now we might think that people are probably not concerned about pollution. Maybe it is just an urban concern, but people are actually indeed concerned about pollution. These are Google search trends on the string air pollution, and literally the peaks align with the PM 2.5 trends that we see in Delhi at least. Even for India, the graph actually looks pretty similar. So you see the peaks in October and November are pretty much the time when all of us are choking. So people are concerned and they are searching. Not all of them might end up buying air purifiers, but that doesn't mean that there isn't a demand for air quality. So there's certainly a demand for air quality, an underlying demand for good air quality. And of course, if people are on internet, then memes would follow. So a lot of them, again, people have expressed their concern about bad air quality, but it doesn't end here. And of course, as Dr. Tabarrok also mentioned, there needs to be more and more evidence that is coming from a developing nation like India. So a lot of good studies have come out from many developed nations, but because of paucity of data, there aren't many studies which are coming out from a country like India. And even if there are studies, they are based on very small samples, but not based on entire India kind of pan-India kind of samples. And that's where we want to contribute. We want to study big samples. We want to study how air pollution affects a really big population set. So these are actually the three, I'm actually picking out 3 studies among many that we are currently doing. But one of the first studies is actually on effect of air pollution on child health. It actually takes the Dean Spears study that Dr. Tabarrok talked about in another direction, which is causal estimation. So you can, the estimates are more reliable because they are based on techniques which can actually lead you to believe that pollution is the factor which is driving these results. So our results are pretty much in line with Dean Spears' results, and we are able to use much more granular data, not just at the district level, but at the location, the village in which a person stays, what kind of pollution figures are in and around their residential location. That is the kind of data that we are able to use when we are doing such analysis. All of these studies, one of them is, of course, as I said, is looking at child health. Another one is looking at cardiovascular health in northern India. The third one is looking at settlement patterns and how pollution is evolving for all districts in India. But all of these studies cannot be done by one person alone. It's an interdisciplinary, all of these studies are interdisciplinary in nature by default. I can be an expert in one area, but we do need atmospheric scientists, we also need doctors, we also need economists, but data scientists as well. So the effort goes into, the effort that goes into all of these studies is a combined effort from experts from multiple domains. So the first study, I'm going to take you through them in like literally at flash speed, but I'm going to show you a few graphs. Basically, this is, if I talk about height for age or weight for age, these are measurements for children, and they essentially are indicator of health of children. In case of India, most of these, even if it may not be visible from far behind, we are far away from the general mean. So most of these figures are actually negative. So we are away from the mean. So if a graph is below the top graph, it essentially shows that that particular group is doing worse. So what we did was that if suppose I divide my sample into children who belong to those areas where pollution was the worst, and I compare them with those children where pollution was the best, which is still doing pretty worse, and you compare them, then you essentially see that you see a vertical gap between these two graphs that's essentially telling you that the health indicators between these two groups are much different, are very different. And the children who are actually exposed to the worst kind of air pollution, they are the ones which are doing much more, far worse than the children who are born in better areas. The effect that we see is actually concentrated towards the first exposure during the first trimester. So during the time when a mother is pregnant, if they are exposed to harmful level of pollution, then you actually see a decline in the future health outcomes of children. Pretty much in line with what Dr. Tabarrok mentioned before, but relying on much more precise estimates for pollution, and also using wind direction and such, which can lead you to believe the causal estimates that we arrive at. The GDP, as again Dr. Tabarrok mentioned, if I'm looking at height for age, that has a long-term consequence on the amount of income that an individual ends up earning much later in their life. If you start calculating these figures, and we are still not able to capture all the effects that it might have in their lifetime, but we still arrive at the figure that the GDP goes down by around 0.18%. And that is, when I'm saying this with a limitation, with a caveat that we are not able to capture all the effects that can possibly occur because you have a lower height, you have lower cognition, you earn less in the labor market, you also end up taking more sick leaves. So by default, you earn less. So these are the kind of effects that we find in our paper. The second paper is with Shamika, Mudit, and a lot of doctors from AIMS, and of course atmospheric scientists. This particular paper is looking at how cardiovascular health is actually affected by crop burning in an area. Again, we are looking at areas which are safe villages, and we are looking at how many fire events or crop burning events actually took place during the last 30 days when they were interviewed and their BP measurements were taken in. And what we essentially find is that if suppose Again, I divide the sample into two groups. Suppose one group is the one which didn't get exposed to high levels of crop burning, but the other group is the one which got exposed to really high levels of crop burning. So the probability of a person's BP falling in hypertensive category is much higher for the people who belong to that group who got exposed to much higher intensity of crop burning, which is the red line, which always lies on top of the dotted graph, which shows that at each age, they started off pretty much similar when they were young, but as you go forward, you see that the gap is actually expanding, which means that older people are much more likely to get affected by harmful effects of crop burning, or in other words, air pollution. Again, few numbers. It's this probability of being hypertensive is a result which holds true for both males and females. The probability for females is around 3.2%. Like the probability of a female being in the hypertensive category because she got exposed to high levels of crop burning is around 3.2%. For males, it's around 5.8%. And there's a huge cost associated with all of these. But because of the high intensity crop burning, essentially you end up again losing GDP because you're not able to work, because you take sick leaves, because a person can also die early and not able to contribute to the GDP of a particular state. And that figure is somewhere around 500 million over a course of around 5 years. But government has actually taken steps to control crop burning. They actually came up with a policy which informed farmers that you shouldn't burn crops, and they also provided them with farm machines so that they can resort to more cleaner avenues of getting rid of crop residues. Although it's a separate paper, but we do see that it did have some effect, but all of us know that the crop burning still happened this year. So there is still a lot to be done in this area, but information campaigns and a mix of various policy instruments is the way to go, of course. And last is the changing settlement pattern and pollution patterns in India. So imagine taking a snapshot of India between 2000 and 2015. And between these two years, the settlement patterns have changed for all districts of India. Imagine that each district of India is divided into 4 categories, where certain percentage is under no settlement, certain percentage is under rural settlement, low density urban settlement, and high density urban settlement. Each district will have certain percentage being divided into all of these 4 categories. But over time, districts are changing. So a lot of districts are actually moving away from no settlement areas to the areas where there is rural density kind of settlement or to high density settlement. And the distribution is actually pretty spread out. The mean percentage by which no settlement actually comes down is around 5%, but you see corresponding increases in other categories. That is that a district actually went from no settlement district to a great extent to becoming an urban or a rural district. And since they are changing, and if you're going from no settlement to high density urban or low density urban, it essentially means that the economic activity is also increasing in those areas. And we would expect that the pollution might also change in these areas. And that's precisely what we are trying to see here. So this particular graph essentially does the following, that it divides our districts into primarily 3 categories. So it's essentially telling you NSR means that a district has primarily gone from no settlement to a rural district. The red one is no settlement to low density urban, and the last one is no settlement to high density urban. By default, you would expect that as a district becomes more and more urban, the PM 2.5 figures will be much worse. And that's precisely what we see. For each year, starting from 2001 till the last year that is there in this picture, you'll see that always the districts which actually belong to no settlement to the group which actually goes from no settlement to high density urban, the PM 2.5 figures are much worse than the other 2 categories. So the transition that is happening in these districts is essentially getting reflected in the pollution patterns as well. So in terms of, we might be doing better in terms of economic growth, but we are also contributing to pollution. And last but not the least, these are again few graphs which are essentially telling you that, again, the top graph is telling you that if you go from no settlement to rural kind of transition, you have some red areas where PM 2.5 actually went up by a lot. But that red zone is actually much bigger for that particular set, where you actually went from no settlement to high density urban areas. So essentially, all of these studies plug into the following narrative that not just we can always we can always look at how pollution affects health and so many other factors, and we can try and attack the sources of pollution. But mostly the solution don't necessarily lie in just one domain. The problem might be crop burning, but the solution might lie in groundwater usage, which is essentially something that the research has found in the past, that there's a groundwater usage patterns which govern how crop burning happens. Or the solution might lie, as Dr. Tabarrok said, EZ pass sort of thing. So, urban planning is something that should be focused on. So these are the kind of solutions, and this is the kind of policy space that needs a lot of discussion.